In this video tutorial, I will be discussing how to determine the structure of molecule by knowing the IR values, proton NMR values, and carbon 13 NMR values. Okay, or combined IR, proton NMR, carbon 13 NMR problems with their solution. Let us discuss the problem one by one. The first problem is a molecule with molecular formula C4H8O6 gives IR values 1743 centimeter inverse, 2850 centimeter inverse, and 1240 centimeter inverse. It gives the NMR values as 1.3 3 hydrogen triplet, 2.3 2 hydrogen quartet, and 3.6 3 hydrogen singlet. In order to determine the structure of molecule, first of all we have to calculate the double bond equivalence. Double bond equivalence, or it is otherwise called index of hydrogen deficiency. Index of hydrogen deficiency or double bond equivalence can be calculated by this equation. That is, double bond equivalence is equal to number of carbon atoms minus number of monovalent atoms divided by 2 plus number of trivalent atoms divided by 2 plus 1. In this case, it will be 4 minus 4 plus 1. There is 4 carbon atom, 8 hydrogen atom. Thereby, hydrogen atom is monovalent, and so 8 by 2, that is 4 plus 1. There is no trivalent atoms in this case, and hence the dBe value is equal to 4 minus 4 plus 1, that is equal to 1. This 1 indicates the molecule may contain one pi bond or an aliphatic ring. Okay, thus this molecule may contain a pi bond or an aliphatic ring. Okay, then the IR values indicates, see, 1743. It is nothing but the value of IR value of carbonyl group, probably of an ester. It is a high value, 1743 centimeter inverse. It is usually the value of or the carbonyl stretching value of an ester. See, 2850 centimeter inverse is the typical carbon hydrogen sp3 stretch of molecule, and 1240 centimeter inverse is nothing but carbon oxygen stretch, particularly of carbon oxygen stretch of an ester. Then see the NMR values. The molecule gives the NMR values as 1.2 3 hydrogen triplet, 2.3 2 hydrogen quartet, and 3.6 3 hydrogen singlet. 3 hydrogen triplet indicates a CH3 group directly attached to a CH2 group. Okay, and 2 hydrogen quartet means this a CH2 group directly attached to a CH3 group, while 3 hydrogen singlet indicates a CH3 group which are not attached with a carbon atom containing hydrogen atom, neighboring carbon atom with hydrogen atom. No neighboring hydrogen atoms present in this, the CH3 group directly attached to a carbon atom without hydrogen atom. The CH3 group is directly attached to carbon atom in either side without any hydrogen atom, or this CH3 group having no neighboring hydrogen atom. Okay, you can see the NMR spectra and these signals. It is 3 hydrogen triplet, 2 hydrogen quartet, and 3 hydrogen singlet as represented in these data. 3 hydrogen triplet indicates CH3 CH2, while 2 hydrogen quartet indicates CH2 CH3, and 3 hydrogen singlet indicates a CH3 group directly attached to oxygen of the ester group. From these informations, we can assign the structure of molecule like this. It is nothing but methyl propionate. The molecule is nothing but methyl propionate. It is the CH3 group attached to CH2 group, and hence this first CH3 group gives a triplet. It is the triplet of this first CH3 group, and then it is the CH2 group which is attached to the CH3 group, and hence this CH2 group gives a quartet. It is the quartet of that CH2 group. Then this CH3 group, the third third carbon atom, this CH3 group, it is not attached with a carbon atom containing hydrogen atom, or it is attached with the oxygen atom, and so it gives only a singlet, and it is the singlet of this third carbon atom or the CH3 group which is directly attached to oxygen atom, and so our molecule is methyl propionate. Okay, then see the next problem. A molecule with molecular formula C5H10O gives the IR values 2984, 2878 and 1716 or 1716 centimeter inverse. It gives NMR values as 0.9 3 hydrogen triplet, 1.6 2 hydrogen sextet and 2.1 3 hydrogen singlet and 2.4 2 hydrogen triplet. In order to determine the structure of molecule, first of all we have to calculate the DBE, the double bond equivalence. It can be calculated by using this equation. DBE is equal to number of carbon atoms minus number of monovalent atoms divided by 2 plus number of trivalent atoms divided by 2 plus 1. For this molecule, it will be 5 minus 10 by 2 plus 0 plus 1, that is equal to 1. That 1 indicates either a pi bond or an aliphatic ring is present in this molecule. Okay, then take the IR value. See the 1716 centimeter or 1716 centimeter indicates a carbonyl group is present in the molecule. Here is an oxygen atom of the carbonyl group, and so the 1716 or 1716 centimeter inverse indicates the presence of a carbonyl group. Then the 2984 and also 2878 are the typical values of CH stretch or carbon hydrogen sp3 stretch. Then see the NMR values, 0.9 3 hydrogen triplet. That means a CH3 group is directly attached to a CH2 group, and 1.6 2 hydrogen sextet, 1.2 2 hydrogen sextet. You can see from this NMR spectra, it is 3 hydrogen triplet and it is 2 hydrogen sextet, and 2.1 it is 2.1 3 hydrogen singlet, and it is 2.4 2 hydrogen triplet. Okay, it is 3 hydrogen triplet and it is 2 hydrogen sextet. That means the CH2 group is attached with a CH2 group and a CH3 group on either sides, and total 5 hydrogen atoms, and hence this CH2 group gives a sextet. The 3 hydrogen singlet is due to the CH3 group which is directly attached to a CO group. There is no hydrogen atom, and hence this CH3 group gives only the singlet. See, this CH2 group attached to a CH2 group, and hence these CH2 groups gives a triplet. By attaching these fragments and considering the molecular formula, it consists of 5 carbon atom. That is why the structure of molecule may be represented like this. It is nothing but 2-pentanone. It is the CH3 group. The CH3 group A indicated as A. It is B, the CH2 group B, and it is the CH2 group C, and it is the CH3 group D. And so the molecule is nothing but 2-pentanol. It is how we can determine the structure of a molecule by or from IR values and NMR values. Okay, and then consider the next molecule. A molecule with the molecular formula C5H10O gives the IR values 2850, 2920 and 1730 centimeter inverse. It gives the NMR values as 9.72 1 hydrogen triplet, 0.98 6 hydrogen doublet, 2.21 1 hydrogen multiplet and 2.6 2 hydrogen doublet of doublet. First of all, we have to calculate the double bond equivalence or index of hydrogen deficiency by using this equation. dB is equal to number of carbon atoms minus number of monovalent atoms divided by 2 plus number of trivalent atoms divided by 2 plus 1. In this case, it will be 1. 5 minus 5, that is 10 by 2, plus 1, that is equal to 1. That indicates the presence of a pi bond or an aliphatic ring in this molecule. Then IR values shows the 2850, 2920 centimeter inverse are typical sp3 carbon hydrogen stretch, and 1730 centimeter inverse indicates the presence of a carbonyl group or C double bond O stretch. Then the NMR value 9.72 is nothing but of one proton triplet, that is a CH2 group attached to a CH2 group. CHO group, the aldehyde group is directly attached to a CH2 group. You know this 9.72 one hydrogen triplet, the 9.72 value is of the CHO group, I mean the proton NMR value of CHO group. It gives 9.72, that is one proton triplet, because CHO group is attached to a CH2 group. Aldehyde group is directly attached to a CH2 group. That is like this. This CHO group is attached with a CH2 group. That is why it gives 9.72 one hydrogen triplet. One hydrogen triplet. Okay. Then we have 0.98 6 hydrogen doublet. 6 hydrogen doublet. That is 2 methyl group of an isopropyl group. See this 6 hydrogen CH3. Both these CH3 groups are attached to a CH group in isopropyl group, and so this both the CH3 group are with the same chemical environment, and it gives only the doublet by interacting the hydrogen atom of this CH group, and so 0.98 6 hydrogen doublet indicates 2 methyl group of an isopropyl group. Similarly, 2.21 1 hydrogen multiplet, that is the CH group. This CH group gives, it is attached with the 2 methyl group on either side, and hence it gives 1 hydrogen multiplet. 1 hydrogen multiplet. Similarly, the 2.36 2 hydrogen doublet of doublet or double doublets, it is because of CH2 group present between the isopropyl group and the CHO group. You can see this CH2 group. It is in between the CH of isopropyl group and the aldehyde group, and so it gives 2 hydrogen doublet of doublet. Both sides 1 hydrogen atom each, and hence this CH2 groups gives doublet of doublet. By considering all these fragments and the molecular formula, by attaching these groups together, you will get the exact structure of molecule like this. It is the structure of molecule. It is 3-methyl pentanol, butanol. 3-methyl butanol. Okay, you can see the NMR values for each groups indicated here, and so the molecule is nothing but 2-methyl butanol. Okay, see the next problem. A molecule with the molecular formula C4H10O gives the IR values a broad band at 3339. It gives a broad band at 3339 centimeter inverse. Also it gives 2850 centimeter inverse and also 1090 centimeter inverse of IR values. Then it gives the NMR values as 0.9 6 hydrogen doublet, 1.7 1 hydrogen multiplet, 3.2 2 hydrogen doublet, and 3.9 1 hydrogen singlet. Having these data, first of all we have to calculate the double bond equivalence or index of hydrogen deficiency by using the equation. Here the double bond equivalence will be 0. This indicates there is no pi bond or any ring present in this molecule. The IR values gives, you can see a broad band at 3339 indicates the presence of an OH group. Presence of an OH group, maybe of alcohol. Then 2850 centimeter inverse is a typical carbon hydrogen sp3 stretch, and you can see 1090 centimeter inverse is of carbon oxygen stretch. It is for carbon single bond OH bond. By considering NMR values, see the NMR spectra of this molecule. It gives a 6 hydrogen doublet. It is a 6 hydrogen doublet and 1 hydrogen multiplet. It is 1 hydrogen multiplet, 2 hydrogen doublet, and 1 hydrogen singlet. These are the datas, and it is the NMR spectra. What information gives this NMR spectra? See, it is 6 hydrogen doublet. It is because of the presence of an isopropyl group. This CH group gives, these CH3 groups both are equivalent, and these equivalent CH3 groups, there are 6 hydrogen atom which gives a doublet, and so we will get a doublet for 6 hydrogen doublet, a 6 hydrogen doublet. And see a 1 hydrogen multiplet. It is 1 hydrogen multiplet. It is of the isopropyl group, the CH group of isopropyl group. This CH group gives 1 hydrogen multiplet. And again, the CH2 group, a CH2 group which is directly attached to CH group, and hence it gives a 2 hydrogen doublet. And again, 1 hydrogen singlet. It is of OH group. This singlet is of OH group, that is around 3.9 parts per million ppm value. See, there is an isopropyl group and also a CH2 group and an OH group. These are the fragments, and by connecting these fragments, by considering the molecular formula, there are 4 carbon atoms, and the molecule can be assigned by this structure. The structure of molecule, it is 2-methyl 1-propanol, 2-methyl 1-propanol. See, it is the isopropyl group directly connected to a CH2 group and an OH group. These equivalent CH3 groups gives a doublet, and this CH group gives a multiplet, and this CH2 group gives a doublet, because by interacting with this CH group, and here is an OH group, and this OH gives a singlet around 3.9 ppm. Okay, and so the molecule is 2-methyl propanol, 2-methyl propanol. Okay, consider the next problem. Molecule with the molecular formula C5H10O gives the NMR values 1.25 6 hydrogen singlet, 3.3 1 hydrogen singlet, 4.8 to 5.1 2 hydrogen multiplet, 5.7 to 6 a 1 hydrogen multiplet, and it gives carbon 13 NMR value as 44, 72, 110.73, 1.46.48. It gives IR value 3300 centimeter inverse. One of the characteristic of this molecule is its peak at 3.3 disappears on shaking with deuterium oxide, determine the structure of this compound. That is the problem. First of all, we have to calculate the double bond equivalent. Double bond equivalent of this molecule will be obtained as 1. That indicates a pi bond or a ring may present in this molecule. Then consider the IR value 3300 centimeter inverse, and also NMR peak shows the 3.3 value disappears, or this peak disappears by adding deuterium oxide. These two values or data indicates the presence of an OH group. Here 3300 centimeter inverse is the typical OH stretching, and if we add deuterium oxide in this molecule, deuterium exchange takes place. Thereby, the peaks at 3.3 will be disappeared. That is the characteristic. Then see the NMR values 1.25, 6 hydrogen singlet indicates the presence of two CH3 groups, 2 CH3 group, 6 hydrogen singlet. But these CH3 groups are attached with another group containing no hydrogen atoms, and hence 6 hydrogen singlet, and these CH3 groups will not interact with any neighboring protons, because it gives these two CH3 groups gives a singlet. That indicates there is no neighboring proton attached with these two CH3 groups. Okay. Then the peak set is 4.8 to 5.1, 2 hydrogen multiplet, and 5.7 to 6, 1 hydrogen multiplet indicates an alkenic hydrogen. An alkenic hydrogen. That is C double bond C. Alkenic hydrogen. Hydrogen attached with the double bond. Carbon-carbon double bond. That may be unsymmetrical alkenic hydrogens, and hence these hydrogens give multiplets. Okay, that is why the molecule may assign by this structure. You can see all these data indicates the molecule will have this structure. See, there are two CH3 groups attached to a carbon atom containing no hydrogen atom. That is why it gives 6 hydrogen. These CH3 groups give 6 hydrogen singlet. Then see an OH group, the OH group of alcohol, it gives 3300 centimeter inverse IR value, and it disappears on adding the peak at NMR, disappears on shaking it with D2 or deuterium oxide molecule. Then you can see alkenic group where these hydrogens are not equivalent, and hence these hydrogens give 2 peaks as multiplets with these values. Okay, and so our molecule is this. Let us consider this molecule with the molecular formula C8H8O2. IR values 1685 centimeter inverse. NMR values as 3.9 3 hydrogen singlet, 7.0 2 hydrogen doublet at 9 Hz, coupling constant 9 Hz, 7.9 2 hydrogen doublet with the coupling constant in the same 9 Hz, and 9.9 1 hydrogen singlet. Carbon 13 values, see the carbon 13 values, delta 55.8, 114.8, 129.8, 132.9, 3, 166.4, and 191.0. This is the mass fragments: 136, the molecular ion peak, 135, 107, 92, and 78. These are the mass spectral values. They are M by E values. The fragments with these M by E values will be produced from this structure. Then how can you determine the molecular structure or the structure of this molecule? First of all, we have to calculate the dBe. dBe in this case will be 5. That indicates an aromatic or benzene ring, and also a pi bond. Then the IR values 1685 centimeter inverse, that is a low value, indicates the carbonyl group is in conjugation, maybe in conjugation with the aromatic ring, that can be seen. Then the proton NMR indicates two doublets of 2 hydrogen each with coupling constant J is equal to 9 Hertz, means para substituted phenyl ring. That is two doublets of 2 hydrogen. Two doublets of 2 hydrogens. You can see the NMR values. Here is a doublet and here also a doublet with the same coupling constant value. That indicates para disubstituted phenyl ring. Okay. Then a singlet at 9.9 confirms the aldehyde group. This CO group is of this aldehyde group. Okay. The singlet for 3 hydrogen at 3.9 shows the presence of OCH3 group. OCH3 group, that is methoxy group. CH3 group, it contains 3 hydrogen atom, but it gives only a singlet at 3.9. By considering all these data, we can assign the structure for this molecule as like this. It is para-methoxy benzaldehyde. Para-methoxy benzaldehyde. These are the NMR, carbon 13 value. Carbon 13 values. It is 55.8, then 114.8, 132.3. Both are same. 132.3, 132.3. 114.8, 114.8. Then 166.4. 191, 191. All these are carbon 13 values. Then see the molecule is para disubstituted. So this hydrogen here and here both are equivalent, and also here hydrogen here and hydrogen here also are equivalent, and so two sets of hydrogen in the ring, and so two hydrogen doublet by interacting with the neighboring hydrogen atom. These two hydrogens are similar or with the same chemical environment, and hence we get two hydrogen doublet by interacting this hydrogen atom. Similarly, these two hydrogens are similar or with the same chemical environment, and these two hydrogen interact with this neighboring hydrogen atom. Thereby, this two hydrogen gives a two hydrogen doublet, and so we will get two hydrogen doublets for this molecule. So the molecule is para-methoxy benzaldehyde. Okay, let us discuss the next problem. Molecular formula C7H6O2. IR values are 3030 or 3030, 3200 to 2700. There is that must be a broad band. Then 1710, 1600, 1515 centimeter inverse. NMR values are 12.5 1 hydrogen singlet, 8.3 2 hydrogen doublet, 7.48 2 hydrogen doublet of doublet, then 7.81 1 hydrogen triplet. First of all, as in the previous case, we have to calculate the double bond equivalence. For this molecule, it will be 5. Then this indicates a benzene ring and another pi bond in the molecule. The IR values 3030 indicates aromatic carbon hydrogen stretch, while 3200 to 2700, it is nothing but the broad band given by hydroxyl group of the carboxylic acid, which is usually concentrated at around 2500 centimeter inverse. Then 1710 indicates the carbonyl group of an acid. 1600 and 1515 centimeter inverse are of carbon-carbon double bond stretch of aromatic ring. And if we consider the NMR values, you can see the one hydrogen singlet is nothing but of COH group 12.5. It is a large chemical shift value, and it indicates the presence of carboxylic acid group, one hydrogen singlet. Then it gives 8.3 two hydrogen doublet, 7.48 two hydrogen doublet of doublet, 7.81 one hydrogen triplet. All these three peaks are of aromatic or benzene ring, and so the ring is mono-substituted because three peaks are obtained. Three peaks usually gives by a mono-substituted benzene ring. That is why the molecule is nothing but the benzoic acid molecule. It is benzoic acid. Thus the probable structure of molecule is benzoic acid. You can see the NMR values. It is 12.71 of carboxylic acid proton, then 8.13, 8.13, and 7.48, 7.48, and 7.81. Total 3 signal for this aromatic ring because of mono-substitution. So, the molecule with this formula C7H6O2 is nothing but benzoic acid. Okay, then see this problem. A molecule with the formula C7H8O gives the IR values 2870, 2910, 3300, 3030, 1480, 1610, 768, and 691 centimeter inverse. It gives NMR values as 9.29 one hydrogen singlet, 2.28 three hydrogen singlet, 6.7 one hydrogen singlet, 6.8 one hydrogen doublet, 7.00 one hydrogen doublet of doublet, 6.66 one hydrogen doublet. Okay, how can we determine the molecular structure of molecule? As in the previous case, first of all we have to calculate the double bond equivalence by using this equation, and for this molecule it will be 4. That indicates a benzene ring is present in this molecule. Then the IR values, see the value 20870 and 2010 centimeter inverse are of typical carbon hydrogen stretch, sp3 stretch. Then 3300 centimeter inverse is indicating the presence of OH stretch. Okay, then 3030, that is nothing but aromatic carbon hydrogen stretch. 1480 and 1610 are nothing but because of the aromatic carbon-carbon double bond stretch. Then these 768 and 691 centimeter inverse indicates there is meta disubstitution, or the aromatic ring is meta disubstituted. NMR value 9.29 one hydrogen singlet indicates the presence of an OH group, phenolic OH group. Okay. Also 2.28 3 hydrogen singlet, that is a CH3 group without any neighboring proton or neighboring hydrogen atom. 6.7 one hydrogen singlet, 6.8 one hydrogen doublet, 7.00 one hydrogen doublet of doublet, 6.66 one hydrogen doublet. All these indicates aromatic carbon hydrogen stretch with unsymmetrical meta substituents. The meta substituents are unsymmetrical. That is why this aromatic stretching, carbon hydrogen stretching, all this aromatic carbon hydrogen stretching, the 4 carbon hydrogen bonds are unsymmetrical, and hence all this gives the 4 signals, because the meta substituents are different. Okay, that is why by considering all these data, we can assign the structure for this molecule as this. It is nothing but metacresol. Metacresol. You can see the NMR values 9.29 for OH and this 2.28 for this CH3 group. It is CH3 and this is OH. Both are different, and hence this carbon hydrogen bond is unique, and this carbon hydrogen bond or carbon hydrogen bond here is another unique carbon hydrogen stretch, gives another unique carbon hydrogen stretch, another carbon hydrogen, because the chemical environment is not same as this, and another carbon hydrogen bond. And so these four carbon hydrogen bonds are different, and hence gives different signals. Okay, so the molecules with the C7H8O is nothing but metacresol. Okay, then it is the last problem. A molecule with the molecular formula C9H10O2 gives this IR values 2850, 1730, 3020, 1620, 1540, and 1240 centimeter inverse. It gives the NMR values as 7.24 2 hydrogen doublet, 7.27 2 hydrogen doublet, 7.22 2 hydrogen doublet, 3.71 2 hydrogen singlet, 3.66 3 hydrogen singlet. Okay. As in the previous case, for determining the molecular structure, first of all, we have to calculate the double bond equivalence with this molecular, with this formula. For this molecule, we will get DBE as 5, that indicates a benzene ring and another double bond is present in this molecule. Okay. Then taking into consideration the IR values, you can see the 2850 centimeter inverse is nothing but the typical carbon hydrogen sp3 stretch, and 1730 centimeter inverse is indicating the presence of carbonyl group, particularly of an ester. Then 3020 centimeter is of aromatic carbon hydrogen stretch, which is confirmed by the carbon-carbon double bond structure at 1620 centimeter inverse and 1540 centimeter inverse. Okay, then 1240 centimeter inverse is nothing but carbon oxygen stretch of an ester group, right? Then NMR values 7.24 2 hydrogen doublet, 7.27 2 hydrogen doublet, 7.22 2 hydrogen doublet, and so 3 ring carbon hydrogen stretches. That indicates mono-substituted benzene. Mono-substituted benzene. Also 3.71 2 hydrogen singlet, that indicates a CH2 group, 2 hydrogen singlet without any neighboring hydrogen on either side. That is why the CH2 group gives a singlet, because the CH2 group is without any neighboring hydrogen atom on either side. 3.66 3 hydrogen singlet, that indicates a CH3 group attached to an electronegative atom. That is a singlet. Okay, and this data indicates the molecular structure of this molecule is like this. It is nothing but methyl 2-phenyl acetate. These are the NMR values. You can see it is an ester. This ring gives 3 signal, 7.24, 7.24. These two carbon-carbon structure are similar, carbon hydrogen structure are similar, and these two carbon hydrogen structure are similar, and the 7.22. So 3 signals are obtained from this benzene ring, and it is 3.71 CH2 singlet and 3.66 CH3 singlet. So the molecule is methyl 2-phenyl acetate. Okay. With this, I conclude my video. Thank you for watching. Thank you.